Welcome to Brain Vision.
This is Chapter 2, Problem 6. So in Part A of this problem, we're looking to find the distance from school to your hometown. And we're given some information about the trip. We're given the total time the trip takes. And then we know that the trip has two distinct legs. So each leg of the trip is some traveling at constant speed, which is the simplest type of motion that we can work with in this chapter. But the two speeds are different, so we can't just treat the entire trip as some motion at constant speed. In the first leg of the trip, we're going at 95 kilometers per hour, so we know our speed. We know that the distance taken is 130 kilometers, but we don't know how much time that leg takes. The second leg, we know you're going at 65 kilometers per hour, but we don't know how much time that takes, and we don't know what its distance is. We do know, however, the total time that both legs took together. So that means if we could find the time for one leg, we could find the time for the other leg. So let's try doing that. Looking at the first leg first, we know the speed and we know the distance. So we know from our good old equation in general, let's do this in black actually, because this is just a general equation not pertaining to any of the legs of the trip. Got average velocity is displacement divided by time elapsed. So in this case, for the first leg, we know delta x, the distance, and we know delta v, and we're trying to solve for delta t. So we can rearrange this to say delta t equals delta x, that's our 130 kilometers, divided by average speed, that's the 95 kilometers per hour. And so we can plug those in. And you'll notice the kilometers are going to cancel. The hours are in the denominator of the denominator, which is the same as being in the numerator. So you end up with 1.37 hours. All right, that's the time for the first segment. So if we want to find the time for the second segment, we can subtract it from the total time. First, you'll notice that our times are not quite in the same units. We've got our time for the first segment in red in a decimal number of hours, and in green we've got it in hours and minutes. So let's convert the hours and minutes to a decimal of hours. There's 60 minutes in an hour, so 20 minutes is a third of an hour, or 0.333 repeating hours. So we can write that as 3.33 hours. And that means the time for the blue trip is going to be 3.33 hours. The time for both, or the time for the blue leg is going to be the time for both legs together, this 3.33 hours, minus just the time for the first leg, the 1.37 hours. And that will get you 1.96 hours. Or about 1 hour, 58 minutes. So we can put that up here. All right, great. So that's useful. And we know the speed and the time for each leg. But what we're looking for ultimately is the distance. So we already know the distance for the first leg. That's our 130 kilometers. So now we just got to find the distance traveled in the second leg, and we'll add that to the 130 kilometers, and that's our total distance. So here, notice, look back at our equation relating average velocity and displacement and time. Now it's the displacement that we're trying to solve for. So we can get that by delta x. Rearrange this equation to delta x is average velocity v bar times delta t. And we plug in the 65 kilometers per hour to our average velocity, plug in 1.96 hours to our delta t, and we find that our delta x is going to be 127.5 kilometers. So for our total distance, we got to take the 130, add it to the 127.5, and you get 260 kilometers. And here I'm rounding, so I'm only keeping two significant figures, because you might also write this as 2.6 times 10 to the 2 kilometers. Because we only had two significant figures in our input, but we've been keeping more as intermediate steps, so we don't end up getting actual errors in our answer due to rounding. But the answer you should report to the best of your knowledge is 260 kilometers for the total distance. And that's part A. Now on part B, it wants what was your average speed. So now we're looking for average speed over the entire trip. Notice that you don't get that by averaging the two speeds that you were traveling at. Because if you think about it, let's say you were traveling at 95 kilometers per hour for a bit, and then 65 kilometers per hour for a bit. Your average speed is going to depend on for how long you were traveling at 95 kilometers per hour, and for how long you were traveling at 65 kilometers per hour. So you can't just average the two speeds because you had a leg at each speed. Instead, what we can do is go back again to this equation. It says average speed, or average velocity, really, of which the average speed is a magnitude, is going to be, for any given chunk of travel, average speed is the distance traveled divided by the time elapsed. So in this case, now we've had to calculate the distance traveled, and we were told the time elapsed. So we can just get that our overall average speed is the quotient of those two things. And now, so we're taking both legs of the journey together as one piece of travel and looking for the average speed. So 260 kilometers divided by this 3.33 hours. Or actually, sorry, what we really should be doing here, we rounded to 260, but you should put in the more accurate numerical value that we had from adding 130 kilometers and 127.5 kilometers, again, to avoid rounding errors. But now you divide this. Now you report your answer to two significant figures. So you've got 77, and the units are just kilometers per hour. And just quickly check, we knew that we couldn't just average 95 and 65 to get our answer in kilometers per hour. But you know that the average speed should be somewhere between those two speeds. And it is. 7 kilometers per hour seems perfectly reasonable. And that's our answer.